Well, hi, good morning. Thank you so much for joining me in my shop, along with my cat Shadow. Today is January 4th. Oh my gosh, we're well into 2024 already. Holy smokes, what are you staring at, cat? Yeah, who knows what goes on in a cat's head? I hardly know what goes on in my own head. Okay, so today is alignment day for this radio. Sure, it seems to be working really well, so I expect this to go fairly well. Yesterday I discovered that this was loose here, and there's another similar adjuster over here. These are adjustable capacitors, but it's not loose. I do not have the alignment instructions, but there are a lot of very similar radios. And this arrangement here is very common in radios that look, basically, they all look like this, basically. Yeah, so like that. And so I could perhaps look at another radio's guidance on which is which, but I think I'm probably going to have to figure it out to be sure of what's going on. So this is a multi-band radio. It's got 6 bands. 1, 2, 3, 4, 5, 6 adjustments here, plus one more hidden over here. It's a 3-section capacitor, but if you see, all the sections are identical in size. In some radios, you'll see one section of the capacitor is smaller plates. In this arrangement, where they're all the same size, there's probably a series trimmer capacitor with the local oscillator, and that's probably what this is over here, the one that's hidden a little bit from view for you, this one here. Probably. Oh, there's another one. Oh my gosh, here's another one. Well, this could be what I just said that one was. This one could be. And the fact is, this one could be the same thing too, this one over here. Why don't we start by tightening this guy up right away? Not much use in trying to align a radio with a loose coil in it. I'm trying to reach past this collar, the locking collar, this part here, down to the nut. Okay, that's solid now. The locking collars, I'm sure there's a special tool for this, or a better tool for this. Do you use these kinds of pliers? Keep your hands away from when you put pressure on, keep your hands away. I don't know if I'm loosening the collar or it's loose already. Well, the collar is not seated right down, so there's still a little bit of play here, so I'm going to leave that alone. Let me try this. So this collar appears to be up also. It's loose. So I think somebody probably tried to, this one also looks like it's up. We'll find out later. These particular adjustments, you have to get a hold of this shaft here. Here. Come get a little better look. You have to get hold of this shaft and pull it up and down, and come up about maybe this high. Pull it up or push it down, you need to also rotate it. That's what kind of make it free, and then you can move it up and down. So to get at this though, I use this kind of tool here. Fit through the hole, and then we can work it. Oh, don't do that. Look at this. Look at this situation here. Come on. It's a coil right here. Careful, man. I can see the base is still loose down here. I didn't get it tight. Lift these collars right off. And we're off to a pretty good start here. Yeah, right away. Use these pliers here. Can I get these in there anywhere? Yeah, not going to grip. I think these are too clumsy. Couldn't see what I was doing there, if I was having success or not. Yes, it's turning. So you see there's a split, I don't know what to call it, a piece coming up. Right? It's split, and when this is screwed down over it, it causes the split parts to move in and clamp onto this, and then it won't move on its own. These things never move on their own. Maybe when they're new. Now I think I can get down on the locking. That should not be loose. Yeah, I was going to say about these pliers. Have you pinched your finger, pinched your hand with them? I'm sure you have. I'm not the only one, I'm sure. Okay, that seems pretty good. Let's try a little better yet. Yeah, can't get it any further. That's good. That's got it. Brass cover, we can leave that off for now, put it on later. You know what, I'm going to put it on now because later I won't be able to find it. Just put it on loose. Yeah, this one's loose to the hand. Not this one. A little more space in there. Big tube out of the way. There we go. Yeah. It's now loose too. Good. Okay, I think we're ready to go. Yeah, I'll put this tube back in because we won't get too far without that. Hey, why don't we just take a moment and test this tube. I don't want to bend the wires too hard. Now, these guys often have a resistor in here. A 1 megohm resistor. And that resistor is almost always cooked. Be down under there. Okay. Bit of a dirty guy. 6 US, 6 GS. Dirty, dirty, dirty. Okay, let's give it a test here. Use this tester on it. Needs to be plugged in. So it is plugged in. I consider this just not turned on over here. This to be my my fast tube tester. When I'm testing a lot of tubes, and I'm not too interested in, are they 100% or 80%. I just want to know that the heater's good and they conduct some current. This is the tester that I use because it's so quick. Excuse me. 6 US. 6 US. Element. S. T. 6U. 6U5. There it is. 6U5. Visual test. Okay, 6.3 volts. Pushing down buttons 1, 2, 3. And the other set is A 4, 5. 4, 5. 18 here. Just this visual test doesn't give any more information. There's another set of settings. Well, let's try and see what happens here. I'm pretty sure this is going to be dead. Most of these tubes are dead in these old radios. No, not there, Jim. It's a 6-pin. Big pins are these two here. Now, there's an arrow marked right on there. Can you see that arrow? Probably not. Right, it's pointing right at my finger. Very hard to see, but there's an arrow. That's helping you identify the two large pins. In you go. On you go. Go ahead and have to douse a few lights here to see. Expect the glow to be there already. Looks like a big nothing. So probably the tube should be glowing in the eyes either open or closed at this point. And then when I reset these numbers here, the eye would do the opposite probably. So A, B, 4, 5, 6. I gotta push the W. I didn't push the test button. Duh. Okay, we'll stay on this part of the test. W. Gotta push W, but let's see what the meter says. Let's go back to the other test again, which is A45. A45. This is a pretty hopeless situation here. 18. The test is WX. No, I don't think this tube is any good at all. Doesn't feel like it warmed up. You can usually see the heater just past the blocking screen. There's a piece of metal in here to block your view straight into the tube. Because if you could look straight in, you would see the heater glowing down there. And, I see no heater. We didn't do kind of foolish. We didn't do the short test. Wow, I'm really bad at this today. I think it's dead. So we can certainly operate the radio without this tube. It basically has been operating without that tube this whole time. What about that cat? Okay, let's bring up the house lights here. Okay, that's a little bit disappointing, but not at all surprising. Let me put this here so I don't lose it. Now the million ohm resistor that's probably in the back of this could still be part of the picture if I put a new tube in there. I do have some tubes that will glow. Put one in there, it may not work right because of this million ohm resistor, which is a bit of a challenge to get at. Okay, I think it's time to start the alignment process here. one of the things I've got to determine is where to hook up my indicating meter. And no alignment instructions. Often the alignment instructions will say hook it up to the voice coil of the speaker. Sometimes they'll say hook it up to the plate of the output tube. At both of those locations, the equipment you're using to do the test can't affect the operation of the radio. But there's other places you can pick up stuff, or you can pick up a voltage. I'm thinking of the AVC voltage. The problem with doing that is it can affect the operation of the radio, unless you're doing it with a fairly good meter. Now today, everybody has really good meters, no doubt about it. A meter like this will do the job. It's very high input impedance. But back in the day, if you had a meter that looked something like this, not digital, but you know, this kind, no, you couldn't use that in this application without affecting the operation of the radio. So a lot of the instructions steer away from things we can do today. Another thing I have here to help me is I have my SDR radio, which has a frequency display. Puts a frequency display on my computer, and we can look at signals and what, in particular, what frequency the local oscillator is operating at when we get around to that. But really, the first stage is just doing these. Now, remember, a loose can here. We got to settle that too. We got to settle that down. So I'm going to tip up the radio here. All I got to do is just find a nut to go on that screw right there. And yeah, so I'm going to get myself a cup of coffee. I'm going to stick a nut on there. And hey, Shadow, what are you doing there? I have a monster of a cat in my shop. Oh my god. I scared him. She scared me. I scared her. Hey. Okay, I'm having fun. You're not supposed to have fun, you know. This work is not supposed to be fun. Who said that? Okay, let's look for a good spot to connect. Now I'm trying to read the rectified voltage that comes out of the IF transformer here and gets rectified in this tube right there. So coming down here is the rectified output, and the audio at this point is recoverable, but it still has RF in it, so that's what this capacitor is trying to dump the RF into the ground. We have a 22K resistor here. If I hook up my voltmeter here, probably that might affect this circuit here, might affect the tuning of this, and that would kind of destroy the whole objective, which is to tune these properly. If I go on the other side here, I'm probably pretty good, probably pretty secure from affecting the radio, and the voltage is going to be sitting here. If I go on the other side of this big resistor, I'm into the high impedance part of the grid circuits on the front end of the radio, and fooling around with these, I'm likely to bleed off some of the charge that's in here and affect the circuit operation and reduce the AVC effector. Do something that probably should avoid. So this looks like the spot in between these two resistors, and if we follow this wire, look at that, it comes out on the terminals on the back of the radio. So all I got to do is just read the voltage on these terminals, the DC voltage, and that should reveal the AVC voltage, which is a function of the strength of the signal coming through this transformer. Perfect. Right on the back. Oh, it couldn't get any easier. Okay, right on the back. So what we're talking about are these up here. And there should be a short installed. Let's take a closer look here. Hard to get my head around here. There's the short. Shorting bar right up there. So those two terminals are carrying the AVC voltage with the rectified output of the IF. Excellent. Okay, so the meter I'd like to use this guy here. Switch them on. And this radio, the negative lead for the voltmeter goes on the chassis. As I get it untangled from everything. Just put this here. The other lead can be connected by clip lead. Onto this back. Okay. That's all there is to that. Make sure that's on DC. Good. Okay. I think we're pretty well set to go. Now this has to be also grounded. I find if you clip onto these screws here, you're on your way to having a floppy connection, because you can't tighten the screw down and stop it from being floppy. So I like to go right on the back here. I think I got it. Okay, I'm gonna turn this guy on. Turn everything on, let things warm up a little bit. Okay, Mr. Radio, you ready? I'd say yes. You can keep an eye on this meter now. It should go up. I have it set to negative, so a negative voltage should take it upwards. Now we're still on the dim bulbs here, so a slow start up. Very, very slow start up. I'm feeding on the signal generator. I left it from yesterday. It's on the IF frequency, so we should get a result. Let's put it on full power here, because definitely what we need to have. This has come up just a needle width. There you can see a little more movement there. Okay, problem. String just fell off. How do you like that? Okay, everybody stop. Everybody stop. Everything stop. Darn it all. I'm going to go drink a little coffee, and then we're going to look at why the string dismounted, but I think I know. I think I know why. We will see. Okay, I'm going to go hide in my coffee cup. Okay, so I think the string has come off because I had the radio on its side, and this wheel may have been interfered with or something like that. I could have had it sitting right on this wheel, in fact. So, okay, we need to put the string back on. It looks like all that's happened here is it's just come off these two wheels. That's all. Goody. Goody, goody. Does suggest it has some capability of coming off. You know, given the right circumstances, and I'm only guessing here. You can hear the spring stretch as I put the string back over the wheel there. Well, tip it on its side again. I have to get underneath the radio to make the adjustments of this and this from below. It has to be up on its side. Okay, let's tip it up on its side here. And make sure that wheel, see, last time I was kind of concerned about the balance of the radio. I ended up pulling it forward. I'm pretty sure I had the wheel blocked. Now, I don't know if you'd be able to see this, but if you look through at the far wheel, it's, you know, it's cockeyed, and that's not helping the situation any. It's not obvious here. Let's tune a little bit and see what happens. See it kind of bending back and forth. I've made no attempt to straighten that. Wow. Very close to coming off, isn't it? Well, I'm going to continue to just work away here, and if it acts up again, then we'll focus more on the string. But for now, let's carry on with the alignment deal here. Oh, no, I was just about to pull the radio forward and set up the same the same problem here. Put on our meter. Yeah, I'm going to keep wanting to pull it forward. Don't pull it forward. Don't pull it forward. I was just starting to wonder why we weren't hearing the oscillator when that happened. That's kind of where we'll get back to. You can see a small, you can't, small voltage rising on the meter here. Wow, what's with the big hum? What's happening? I could be tuning in the harmonic of this, of the signal generator. Yeah, that's what's happening there. We don't want to hear that, but we do. I think it's also picking up some signals too. But we should be able to hear this coming through the, just coming straight through the IF. It's feeding in the IF frequency. Maybe it's not enough signal strength. It's a little better. Let's check the calibration on the old guy here. Too high. Okay, so that's calibrated at 10 microvolts, and this is the multiplier. Right now it's times 100. That's 1,000 microvolts, 1 millivolt. Okay, we can hear it. Now the important thing is it making the meter go up? Of the camera, so I'm just going to move this here, and I'm going to fool with the signal generator here. It's just barely moving this. Dirt in my control here. Let's go up another big chunk here. Something not right. Something's not right. The meter should be going way up. Well, let me change the frequency over here a little bit. There we go, changing the frequency. Oh my. Why so different? So it's a little different than yesterday. I'm getting 454, it was 458 or something yesterday. videos are we tune the radio back. Oh no, not tune the radio. Tune the signal generator, and we'll watch the meter again. It's just barely changing. Something not right. Something is not right somewhere. I think I'm going to put the antenna on it, and we're going to watch the AVC voltage variation with a regular radio signal. Something so we can hear the radio operating. We know it's working right. I'm going to have to run and turn on the antenna here. So I'm just going to stop for a sec because my coffee cup is near the antenna switch, so I'm going to stop and visit my coffee cup a little bit. Okay, so the antenna switched on here. I think I don't know for sure this is on the right band. So yes, it is. This is the broadcast band. I'll watch this meter as I tune the radio around a bit.
Community rewards program. City News Time 9:34. We are starting to see that's been missing for weeks. Gotta vote for me to stop this. One listener texting, well, some of us welcome the Maple MAGA label. I haven't heard that before, Maple MAGA. It's not an insult to want a leader who wants the best for his country. I'm sure we're going to hear a lot about this petition.
Well, that's some kind of insight.
That's calming, relaxing. Love it. You got to love it. The news is about to end now.
Volume down here.
Yes, they're fun again. They're washable. Yeah.
That's the strongest station there. 590 right there. So the strongest signal is giving a voltage of, this is 5 volts. So this is only 1.5 volts. That's not very much at all. I wonder. So another spot would be to go beyond the big resistor. Man, wow, I'd have to find it in here too. Let's see where we're connected right now is it's up on top of the chassis actually. The connection. So wires coming down somewhere somehow. Wow, take me a while to sort that out. Yeah, I'm not too sure what to think here. I've certainly got this done correctly. This is done correctly. Everything's correctly. And we're getting a little voltage. Let's suppose we take the 6K7. That's the first tube the signal reaches in this radio. 6SK7. 6SK7. And we see if in here there's a hint as to what kind of bias voltage it would be looking at. Grid number 1, control grid. Positive bias value. What is that? I don't even know what that means. 0. A positive bias value. I don't know what they're talking about there. Grid. So here, grid number 1, voltage, -1, -3. Oh, it's not at all what I thought. I thought these twos were looking for minus 10 volts of variation in the AVC that's coming its way. So in fact, it's actually getting, assuming you could put a much stronger signal yet into the radio from what I'm doing with a better antenna, yeah, maybe you could push it all the way up there. And it says -1 under the category of there is no heading on this column. So this is based on a different plate voltage. So plate voltage is probably more like 250. So there we are, -3. Maybe it says something here. Control grid bias. Variations will be found effective in changing the volume of the receiver in order to obtain adequate volume control, an available grid bias voltage of approximately 50 volts will be required. What? In order to obtain adequate volume control, an available grid bias voltage of approximately 50 volts will be required. The exact value will depend upon the circuit design operating conditions. This voltage may be obtained, depending on the receiver requirements, from a potentiometer, across a fixed supply voltage, from a variable cathode bias resistor, from the AVC system, or from a combination of these methods. 50 volts. Come on. Really? 50 volts. The next tube is a 6SA7. What does it say? 6SA7. 50 volts. Where's that going to come from? So 6SA7. I'm just looking down here for volts. It talks about grid number 2, grid number 3. What about grid number 1? Number 3, number 2, number 4, typical operation. Here we are, grid number 1. Grid number 1 resistor. What are they talking about? Grid number 1 current. Oh, you know what? They're using grid number 1 for the oscillator. That's what's going on. So grid number 3. Grid number 3, control grid voltage. Just -2. -2. Installation and application. Does it say anywhere about because of the special structural arrangement of the 6SA7, a change in the signal grid voltage produces little change in cathode current. Consequently, an RF voltage on the signal grid produces little modulation of the electron current flow in the cathode circuit. This feature is important because it is desirable that the impedance in the cathode circuit should produce little degeneration or regeneration of the signal frequency input and intermediate frequency output. Another important feature is that because the signal grid voltage has little effect on the space charge near the cathode, changes in AVC bias produce little change in oscillator transconductance and in the input capacitance of the number 1 grid. There is therefore little detuning of the oscillator by the AVC bias. So what I'm getting out of that is the tube is relatively insensitive to variations in the AVC voltage on the control grid, and the value of that is it doesn't disturb the oscillator portion of the tube's operation. So the local oscillator remains fixed. It doesn't drift up and down as the AVC goes up and down, which of course would be a disaster for the radio. So, okay, the small voltage. Wait a minute, it said 50. I don't know. 50 was for the grid number 1 on the, yeah. Okay, it's good. I'm good. It's good. All is good. All is good. So now we can actually do the work. I haven't put the nut on the bottom of that can yet. We can't do this until I do that. Oh my gosh. I was debating whether I would turn the camera on because this could be fiddly, but this is how I'm going to try to do it. I can't get my fingers in there. So I just got the nut on the end of my pliers. Yeah, debating whether to put this on camera because this is close to embarrassing. If I used embarrassment to control or decide what I post, I don't know, about half the stuff I do I wouldn't post. That's not working. Tried the straw thing here. It won't hold the nut. just knocks the nut out. It's not enough grip. This definitely is one of these sooner or later it'll work things. Later. Apparently it's later. Okay, I'm going to try to stick my fingers. Let me just make sure this is just grounding the wires that are there, just in case. One of my safety rules is unplug the thing before you stick your fingers in it. Yeah, it looks like it was really unwise for me to turn on the camera. Hey, I got an interesting idea here. How about we try a magnet? Oh yeah. Oh, I like this idea. As soon as I get close to the, get the nut close to the screw, it leaps off the magnet. I don't even know this nut is the right size. For crying out loud. He's crying out loud now. So I could easily be putting on the wrong size here. Try a bigger one. Yeah, really. Let's try a bigger one. That's a little bigger. Bingo. Yeah, wow. I'm trying my best to put on the wrong size nut. Yeah, once again. It probably would have been better had I not turned the camera on and done this in peace. So we have to clamp this down so the can doesn't move relative to the coils inside it. Or that could potentially cause them to tune off a little bit. I think it would be a very small amount. But you also, assuming the other nut is holding on solidly, a bit of an assumption. It's completely loose too. What happened to this radio? Somebody took this can off, put one nut back on partially, and then just walked away. I don't know. I don't know how you explain that. Yeah, this nut is way up. Ow, 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 ow. I'm gonna pinch your finger. I'm saying ow, I didn't actually get hurt. It's just it was a close call there. Yeah, I was talking about these pliers again. Biting your fingers because you get them too close to the business end. I got a pair of, oh, this is not working. I got a pair of killer pliers here. Was it the ones I had out? These kind here? So that's a deadly spot right in there because you can get your finger in there and then, ooh. But you know, if you do this kind of stuff, you've done that. I'm sure of it. Can you just turn this with my finger? No. We're going to have to struggle along. So I'm now making a video of me tightening the nuts. Now this is not going on well at all. Doesn't look tight. There's a lock nut. I think there's a lock washer under that. Looking at the other ones, better check the other ones. This is why I like to unplug the radio when I'm doing anything, because I start down here where it's fairly safe, but now I'm poking right around here. That's right by the power cord. So, you know, you could say to yourself initially, I don't need to unplug that, and then this one's loose too. Now they're all loose. I just saw the whole transformer move because I yanked on that wire here a little bit. So, well, if these have got locking nuts, they're not locking any. This is loose too. They're all loose. Why would that be? That they would all be loose? Wow. Let's just wiggle the top here. So the can feels rock solid. And the lower one also feels rock solid. So I think we're good enough. So I think I'm probably compressing a lock washer. Probably what was happening. Okay. I don't know. I think we're ready. Are we ready? Is anybody ready? Anything ready at all? We have to have it tipped up. The wheel is free, but we shouldn't worry too much because shouldn't have to tune the radio. I've experimented with the radio, found out the AVC voltage really is low. Book says that's okay. Radio's working well. So I guess that is the case. It's just a very, very low. Okay, now the proper AVC, proper frequency, I'm just going to double check here because I don't want to be wrong about that. 456 kilocycles. 456 kilocycles is what it says in the manual. So we'll set this to, well, we'll get there in a moment. Let's turn the radio back on. So plug it in. This is called a visible point of isolation, where you can see with your eyes that it's not plugged in. With a switch, the switch isn't visible inside. Yeah, you can see the handle on the switch, but you cannot see the blades inside. Now, it may not mean much to us in our homes, but back when I was working in the power company, a line person had the right under law to see the point of isolation. So that was done in two ways. They don't have a big plug to pull out. Instead, they put a glass window on the switch panel, and you can look in through the window and you can see the blades, and you can see that they've separated. So you know the circuit you're going to work on is dead, and you have a legal right to come and see that with your own eyes. Back when Ontario Hydro, or when Ontario here in Canada generally was electrifying, and of course it was early here in Ontario because of Niagara Falls being a huge source of electricity. Once they got into really developing the electric system and building it out and getting it into the farmland and through all the cities and all that kind of stuff, and that went on like it did all over the world, same thing here. Basically from around 1910 to say 1950, just after the Second World War. There's a big build out going on. The death rate for the company that was doing the build out was one person a week during that period got killed. And believe it or not, most of them, or many of them, drowned because of a lot of hydro projects that involved guys getting in little boats out in rocky rivers, falling out and drowning. Yeah, drowning. Okay. I'm happy to say the death rate now in the power system in Ontario is more like one person every 5 years or something like that. I don't really know what the statistic is. While I worked at Toronto Hydro, I was there for a little under 30 years. 6 people lost their lives. Most of them were in car accidents, being run down on the road because you're working on the road in the city. Yeah. Okay, sad topic. There we are.
Appreciate you jumping on.
Thanks so much for having me, guys.
All is operating.
Great Katie Heindel does some excellent work. NBA reporter
I'm going to tune away.
And she does
Do a quiet spot. Take it off the antenna. That's very important. Off the antenna here. Okay, and over onto the signal generator. And we're not hearing anything. Pourquoi? We should be hearing this, shouldn't we? Okay, 456 is where we're heading. Okay, now there's a little tone there. Because the radio is also picking up other signals and they're heterodyning with it. So we just want to get rid of that. Get into a quiet spot. Is there a quiet spot? That's the harmonic of the signal generator being picked up by the radio itself. Does it feel like this string is ready to dismount? So something is binding here, but we're not going to investigate that right now. We're going to just stop here. Very hard to find a spot without a little heterodyne. Okay, good enough. Now it's all about the meter. Making that meter go up. So let's see if I can get it in the shot here. See what I'm doing and kind of see the meter. Okay. What am I going to do now? I want to adjust the I want to adjust the core of the first transformer. It's this one here. Oop. Okay, now we got to watch this meter. I got to put a little more juice in it here. Okay, I'm watching this meter. Okay. Now I'm going to go ahead and do the bottom of the other one too, because it's just too convenient to not do it. What's that? What's that buzzing there? There we go. Okay, we're watching the meter again. Down. Pretty much bang on. Right there. Now we'll do the top. The top I can just hold with my fingers, I think. Probably could, but I'm not gonna. Okay, ready on the top of the first, watching the meter. $16 miles out. Look at that. Oh my gosh. Are you serious? This is totally unexpected. Wow. Wow. You know, I was quite convinced this was not far out. Holy smokes. Let's do the bottom one again. Get on there. Ah, so frustrating. There we are. I'm going to knock back the signal generator. Still on the right frequency. Watching the meter. Didn't make any difference here. Still the same spot. can't believe how much came out of that. You know why? You know why? Because those ones are on the top and people can reach in and go like this. And blaming it on somebody. Okay, now we're gonna... People, all kinds of people. People, you know, passing by in the street, they can reach in and turn that. Here we go. Next one. We're gonna get a big boost on this one. Not a big boost, just a little boost. Well, this is a huge difference. I mean, the radio was really working well before. Holy smokes. Holy smokes. Okay. Let's put the antenna back on and see what's happened here, because this highly sensitive radio has become stupidly sensitive now. Oh, okay, I gotta move. You gotta move. You're in the way. You gotta stand over here. Okay, back on the antenna. And let's tune somebody in. Okay, I'm at the high. Oh, this was where the string appeared to be. Okay, so I can see what's happening. The wheel that's holding the string, way up at the far corner there, has moved inwards and is also, because it has this warp, is coming up against the front panel. Scraping and causing drag at the front panel. Don't think that's going to cause the string to come off. It's just I can feel it. Yeah, I'm going to have to try straightening that wheel out because it's scary. Okay, there we go. Oh, you know, we gotta watch the ABC now. Now I'm on the 5-volt scale again. So let's go up here. Okay, that's the 15-volt scale, so we're kicking around 5 volts right now. We tune the radio.
Frank was a German-born Jewish girl whose family went into hiding from the Nazis in Amsterdam during World War II.
We're going to go for the big station at 590.
Clear, low near minus.
Weather.
For today, our guaranteed high already reached +1. Right now, we've got lots of sunshine out there. It is -6, feeling like -13 with the wind. City News Time 10:03.
Well, that didn't make sense to me. Yeah.
Toronto police has data from
Very cold here today.
Jack is with the United
Finally.
Jewish Alliance and was a guest this morning at 640 Toronto. This is hate targeting Jewish people in the city of Toronto.
640. That'll be 610. Here it comes. 590.
On January 19th to 28th at the Endercare Center. Are you ready?
Yeah, I'm ready. I'm ready. 6 volts. Very good. Well, okay. I think I'm going to stop here. We're ready to do the remainder of the alignment. I don't know what to expect now. I'm so surprised by how much boost I got out of the IF here. I was totally convinced that it was relatively well tuned. But it sure wasn't. Wow. Fantastic. Okay. That's it for today. Thank you very much for watching. I hope you're getting a kick out of this. And tomorrow we'll carry on with the rest of the alignment. It'll be a fairly involved process because there's 6 bands and I'm liable to make stupid mistakes along the way. But in the end, wow, this will be one hot receiver. All these radios of this style, I find, work really well when they're tuned up. Okay, that's it. Have a good day, and see you tomorrow.